Hello, Coach Travis here with another pre-calculus video this time. This is a problem about graph transformations. So the idea is that if you know what the graph of a function is, so the idea is we know this function, this dotted function here is called f of x. And the point is I don't know what the formula is. I don't know the formula for this function. All I know is the graph. But even if I don't know the formula, then I can still, if you manipulate this function algebraically, you can still predict what the graph of the new function is going to look like, even if you don't know the formula for the old function. So basically the idea here is that kind of if you know the graph of a function, then in some sense you know everything that you need to know about the function. And so let's see how that goes. Let's see, what are we trying to do? So we know the graph of f of x is this dotted function. And then we want to know what the graph of this, if we make these algebraic modifications to the original function, we have to predict what the new graph is going to look like. Okay, so anyway, so the way I do these problems is it starts off to me very confusing because there's two pictures. So what I want to start by doing is moving this solid line so that it overlaps with the dotted line. So the idea now is I'm just looking at the function f of x. So I'm looking at the function f of x right now. And so now I want to think about what are these algebraic transformations going to do to the graph. So I try to, in general, you want to work from the inside out. So when I look at this, the first transformation I see is that the x on the inside is turning into x minus 4. So if you review the graph transformation rules, when you replace x by x minus 4, what that's going to do is that's going to shift the graph to the right by 4. So subtracting a 4 from the inside moves us in the positive x direction by 4. So that's the first transformation. And then the next, so now working my way out, I see there's a negative in front of the f. Okay, so if you think about the graph transformation rules, they say that when you multiply the outside of the function by a -1, what that's going to do is that's going to be a reflection across the x-axis. It's going to be a horizontal reflection, or maybe that's probably the wrong way to think about it. It's going to be a reflection across the x-axis. So the moral is that this point, basically what it's going to do is, basically it's going to turn all the y, it's going to flip the sign of all the outputs. It's going to flip the sign of all the outputs, and the outputs we know are y coordinates. So basically all of our y coordinates are going to flip sign. So this point right here used to be a positive 4, and so now it's gonna go to -4 because it got flipped. So the point where things that have y coordinate 4 are going to turn into y coordinate -4, and the x coordinate didn't change. The x coordinate was 6 if I did it right. The x coordinate didn't change, and it remained at 6. Okay, and then so now the last transformation here is the +1, and the rules of graph transformations tell us that when you add a 1 to the outside, that's going to increase all your y coordinates by 1. And increasing your y coordinates by 1 just means that the entire graph moves up by 1. And and then I'm all done. So if I did everything right, that should be the correct answer. Let's take a look. Just to double check. And sure enough, yeah, that was it. So that was the correct answer there. And so the idea that on these, what you want to do is you kind of just want to work from the inside out, or I guess I should say you start by lining both of the functions up, and then work from the inside out, applying all of your graph transformations.